Okay, so let's continue. Now I want to introduce the idea of random variables to you. Random variables are a very convenient way for us to express some specific events and for us to better analyze probability problems. Okay, so let's study this tool. A random variable is a variable whose outcomes are random. Okay, so the definition is just so simple. Some examples are here. The outcome of tossing a coin is random. Okay, so we may define a random variable as the outcome of tossing a coin. Then its possible values will be head or tail. Okay, that's a random variable. Or another random variable may be the outcome of rolling a dice. Then that's also the outcomes are random, and then this is a random variable. If we survey 25 people about whether they prefer Pepsi to Coke, then the number of people preferring Pepsi to Coke is also a random variable, whose value may be from 0 to 25. Okay, random. If we ask how many consumers will enter a store at 7 to 8 p.m. tonight, then that's also a random variable. The values may be 0 or 1 or 2 or 3, blah blah blah, whatever. The possible values are some integers, and we don't know it, but we know the outcome is random, so this is a random variable. The temperature of our classroom at tomorrow noon, this is also something random, right? Before that, we cannot really know what will be the temperature. We may predict, but that may not be accurate. Finally, if I randomly select 10 of you and ask you how many hours do you spend in this course in each week, then the average studying time will be random. Okay, this is because each time when I select 10 students, I may select a different group, and then of course the average will be different. So all of these are random variables. A random variable may be discrete or continuous. For discrete random variables, the outcomes are counted. Those values are counted. For example, tossing a coin is either head or tail. We can count there are 2 outcomes. For rolling a dice, we can count there are 6 outcomes. For Pepsi versus Coke, we can count the possible outcomes are 0, 1, 2, 3, 4, blah 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 blah, 25. So the total possible outcomes, there are 26 possible outcomes. And finally, the number of consumers entering a store. Okay, it may be 0, 1, 2, 3, blah blah blah, or it may be 100. It may even be 200, 300, or any possible numbers that are larger. Okay, so we probably need to say there are really a lot of possibilities. But what's important is that we can count those possibilities. It must be something that are countable. Okay, 0, 1, or 2, or 3. They are just discrete, right? For continuous random variables, it's different. Their values are measured instead of counted. For example, the temperature of the classroom at a specific time point, that's not something that is countable, right? We cannot count how many possibilities there are. The value must be measured instead of counted. Or the average studying hour, that's also something that must be measured. Mathematically, we say a discrete random variable has gaps among possible values. Like between 0 and 1, there are other values, okay, 0.5, 0.7. But if we are talking about number of consumers, there are gaps between those integers. For continuous random variables, their values are somehow measured in intervals, okay? Because all those possible values we see in this number and that number are possible. So possible values form an interval. Okay, discrete versus continuous is a very important thing to differentiate. Okay, as we will see, when we have discrete or continuous random variables, the methods to deal with them are somewhat different. So keep in mind that you need to have some ways to distinguish whether a variable is discrete or continuous. So now, if we are talking about random variables, we want to have a way to describe a random variable. To describe a random variable, first, we may write down all the possible values, or the sample space of that random variable. But of course, that's not enough, right? Because for each possible value, we also need to describe how likely it will occur. Different values may have different likelihoods to occur, and that's something we need to describe if we want to make a precise description about our random variable. So, if we combine these two things together, if we list all the possible values and how likely they will occur together, then we are providing a probability distribution of that random variable. A probability distribution is just, for those examples you will see today, it's just a table listing possible values and their likelihoods or probabilities. Okay? Today, we will only talk about discrete distributions because they are easier to understand at the beginning. In the next week, we will talk about continuous distributions and some more applications. So let's start with this example. For a discrete random variable, we will first list all the possible outcomes and then for each outcome the probability. So if I say x is the result of tossing a coin, then possible values may be head or tail. If I say small x is an outcome, then for each outcome, I may write down the probability for my random variable x to be that outcome. So probability for x to be head is 1/2, and the probability for x to be tail is also 1/2. That's the probability distribution of x. Okay, that's the distribution of x. If x is the outcome of rolling a dice, a fair dice, then the probability distribution will be 1 with probability 1/6, 2 with probability 1/6, and so on and so on. I list all the possible values and their probabilities. That's a probability distribution. And given this, I can fully describe a random variable. Okay? Sometimes we will abbreviate something like this as just PR of x if we all know what is the random variable we are talking about. Okay? And this probability function will generally be called as probability mass function or just probability function of that random variable. Today, we will talk about probability mass functions for discrete random variables. In the next week, we will talk about probability density functions for continuous random variables. Okay? We will tell you what are the differences about them and what's the meaning of those names, mass versus density. Okay? But here, just intuitively think that for each possible outcome, there is an associated probability. That's something you need to know. Finally, for any random variable x, we know this is true. That is, for all the possible outcomes in the sample space, the sum of their probability must be 1. Okay? So, as a more complicated example, let's consider tossing 2 fair coins or tossing a fair coin twice. So this is the second. Suppose I say x1 is the outcome of tossing a fair coin for the first time. x2 is the outcome of tossing a fair coin for the second time. And then I write y to be the number of heads I can get by tossing this coin twice. And then I want to know the distribution of y. Okay, distribution of y. The possible values are 0 or 1 or 2, right? You toss a coin twice. The maximum number of heads you may get is 2. Okay, so the possible values are 0, 1, and 2. How may we also find their probabilities? That's a question. So for this particular problem, we probably need to break down into these two basic or more elementary variables. Okay, so we can say, okay, the probability for x1 to be head or the probability for x1 to be tail are both 1/2 and 1/2. That's something we know. And also for x2 to be head and x2 to be tail, that's also 1/2 and 1/2. So for each element here, for each entry here, we multiply 1/2 with 1/2 to get the joint probability. The joint probability for two heads is 1/4. The joint probability for tail and head is also 1/4, and so on and so on. And then we may get our probability distribution of y. For each possible value of y, we know we can write down its probability. For 0, that means tail and tail. Okay, so it's just 1/4. For 1, it means head tail or tail head. So that's the sum of these two numbers. That's 1/2. And finally, for 2, it's head head. So its probability is 1/4. Okay, so for a composite random variable y like this, if we want to find its probability distribution, then we need to break down to elementary random variables. Okay, just like if we want to measure the probability of one event, we need to break down to elementary events. Okay, so that's the end of this example, but you probably want to do some exercises by yourself about if you toss a fair coin for 3 times, what's the number of heads that you may get, and what's the distribution of that. Okay, if you can correctly find a distribution for the number of heads obtained by tossing a fair coin for 3 times, I believe you have fully understood what's the concept of random variables and the distributions. Okay, try to do this by yourself. Thank you.